Alright, so 2.6, we are solving inequalities and graphing their solution. So, how do I solve inequalities? You solve an inequality just like solving an equation. Okay, the only thing we have to remember is that if you divide or multiply by a negative, so if we divide or multiply by a negative, the inequality flips direction. Okay, this should be that should just be a reminder for you, correct? We know that if you multiply or divide by a negative, the inequality changes direction. But other than that, we just solve exactly like we've been solving before. So whatever we do to one side, we have to do to the other. Good.
We don't change it.
Okay. So, what are the steps to graphing? So there are steps to graphing because I know it's been a while. So our main thing is that we want to get x on the left-hand side. So we always want to get x on the left-hand side by either subtracting or adding. And just remember that you must flip the sign if you have to. Okay? So we're always going to try to get x on the left because that's going to make it easier for us to graph. Because whichever direction, if our x is on the left, whichever direction our arrow is pointing, that's where our arrows are going to go. Okay? We want to plot the constant on the number line. And then we need to determine if the point should be open or closed. And I'm going to give you a nice little chart in a second to help you decide. Alright, so how do I know if the point should be open or closed? Here's a nice little chart for you. Yes, you do. Okay, so the main thing that I like to remember on how to determine if it's open or closed, if there's an equal sign at all, then we have an open point. Oh my gosh, I did not type this out correctly.
So we don't have to write it down?
Yes, you do. I'll fix it.
You're so bad at drawing graphs. Will you draw?
Okay, so basically if there is an equal sign, our point is solid because that means we can be touching the point. So an equal sign, we have a solid point, it's shaded in. If we are less than or equal to, greater than or equal to, or less than or equal to, our point is solid also because it has that equal sign underneath. Okay, because we can touch it, so we shade it in. If we are greater than or less than, we have an open point. And the way that I remember that is it's like a fence going around that point. We can't actually be equal to that point. So we have to draw a fence around it, which means we have an open circle. Okay? Alright, so if we have an equal to at all, 1 or 2, those have equal tos. We have a solid dot. We can touch it. If we do not have an equal to, like number 3, greater than or less than, we have an open dot. Okay? Alright. Last step is to graph the line that represents the inequality. So after you draw the point, you're going to graph the line. So, if we have an equal to sign, there is no line. It's just a point. If we are less than or equal to, so our arrow is pointing to the left, our line is going to be going to the left. If we are greater than or equal to, our arrow is pointing to the right, our line is going to go to the right. Okay? Remember, x has to be on the left-hand side in order for this to work. Okay? Example 1, 2 is greater than 6 plus x. Okay? So let's do all the work and then we'll draw the number line. What is step 1?
Get the x on the left.
Get x on the left-hand side. Is x on the left-hand side here?
No.
No. So how will I move it to the left?
Flip the equation? Oh, you said flip it. Yeah, you flip it.
Flip it if you have to. So it is okay for us to rewrite it like this. X plus 6, or 6 plus x, I mean, sorry. 6 plus x less than 2. So we just flip the whole thing. Yes, they're the same thing. Why? What is, you guys remember the alligator?
Yeah.
What's the alligator eating in this one?
2.
The 2. What's the alligator eating in this one?
The 2.
Still the 2. So they're the exact same thing. So you can just flip the whole thing. Okay? So just flip it off. Alright, so now we have to get x by itself. So how do I get x by itself? Subtract it. So that is going to give me x is less than negative 4. We're done.
Oh my goodness.
All we have to do next is graph. So I like to put 0 in the middle. And then we'd have 1, 2, 3, 4, and then let's put 5. Negative 1, negative 2, negative 3, negative 4, negative 5. Lots of graphics.
I know, don't try this like 10 times a day.
Okay, so step 2 is to plot the constant on the number lines. My constant is negative 4. So I know I'm going to put a dot at negative 4. Is my dot open or closed? Does this have an equal sign on it?
Open.
No, so it's open. There's no equal sign. So make sure that you make an open dot, please. If it even remotely looks closed, I have to take points off.
Okay, so what about this?
Okay? That's good. Alright, now I need to determine or graph the line. Is my arrow going to the left or to the right?
To the left.
To the left. And let's think about it. Doesn't that make sense?
Yes.
X less than negative 4. Where are all the numbers that are less than negative 4? To the left. So we want our arrow going to the left. So my answer is x less than negative 4, and here's my graph. Okay, example 2. X minus 6 plus 10 greater than or equal to negative 8. X minus 6 plus 10 greater than or equal to negative 8. Is x on the left-hand side?
Yes.
Yes. So now we just get to start solving like normal. So do you guys see anything we can do on the left-hand side? Perfect. We can add negative 6 and 10, which is called combine, like terms. So this is going to be x. Negative 6 plus 10 gives me plus 4, greater than or equal to negative 8. And then to solve for x, subtract 4 from both sides. And I get x greater than or equal to negative 12. Okay, Tegan said something really, really good. So x equals negative 12. No. X is greater than or equal to negative 12. I see this so many times on tests, guys. The symbol does never changes to equal. The symbol has to stay the same. Okay? Alright, so negative 12, that means we're going to have to draw a lot of lines. So what I'm going to do is let's put 0 in the middle. Where would negative 12 be? To the left of 0, to the right? To the left. So just somewhere over here, let's just draw a line and say it's negative 12. Is everybody okay with that?
Yes.
Okay. So let's plot our point. Greater than or equal to, solid or closed?
Solid.
Solid, why?
Because it's equal to.
Because there's an equal to. And then which way is my arrow going? To the right. Okay. Example 3. 5 minus 3x greater than or equal to negative 10. 5 minus 3x greater than or equal to negative 10. Is x on the left? Yes. So, now we just get to start solving as normal. So what do you guys think I need to do?
Subtract 5.
Perfect. Subtract 5 from both sides. So that gives me negative 3x greater than or equal to negative 15. And then what? Divide by -3. Okay. So that gives me x. What happens when I divide or multiply by a negative? The sign flips. So this becomes less than or equal to positive 5.
Because isn't a negative sign and negative sign?
Yep. Okay, so let's 0. Is 5 to the right or to the left?
To the right.
To the right.
To the right.
Is my dot closed or open?
Closed.
Closed, because there's an equal. And where is my arrow pointing?
To the right.
To the left.
To the left.
Okay, because we divided by a negative, so you have to flip the sign.
I didn't get that.
Okay?